All right, hello everybody. This is going to be a solution for a question involving the graph of a function, and we need to find the domain and its range, and we're asked to write the domain and range in interval notation. So here we have the graph of the function, and then let's just remind ourselves of a couple things. Remember that the domain is a set, right? Is the set of all input, and in this case, it's going to be x values, input values for our function, okay? So for our function f. So that's the domain, and then range is similar, but is the set of all output, and in this case, it's going to be y values uh, for f. I'm going to write the same thing as I did earlier for your function f, okay? So that means we need to see from just by looking at this graph, what are all the possible x input values that we're using, and which are not. So notice that, for example, x equaling 3, that x value corresponds to no point on the graph. That means that x being 3 is not an input value, so it is not in the domain of our function. Okay, and then notice that at x equaling 1, that x value is part of my graph corresponding to this point here, which means that 1 is an input value for my function f. So it would be included in our domain. And so by looking at the graph, whenever you're looking for the domain, you want to focus just on all the x values, so all the numbers on the x-axis, and kind of visually ask yourself, which x value is corresponding to a point on my graph? If it is corresponding to a point on your graph, that means it is an input for your function and it is in your domain. So because for both domain and range, you're going to express them in increasing order, we usually try to find the smallest value for the domain and range. So let's focus on the domain. So we know 1 is in the domain, but you want to see what's the smallest x value in your domain. Now you might be tempted to say that -6 isn't the smallest value, but the whole entire purpose of writing an open circle is it means that you're anything a little bit greater than -6, so like -5.9, if I zoom in, -5.9 would be, oops, it's really big, would be around here, and it is corresponding to a point on my graph. So -5.9 or anything just a little bit bigger than -6 is in my domain, but -6 itself is not in my domain. Okay, so that means that if I try, let's say I have a function and I try to plug in -6 into my calculator, it's not going to output anything. It's going to say error, or it's going to say that it's undefined. Okay, and so that tells me that -6 is not in my domain. But anything greater will be uh, corresponding to a point on my graph, which means it will be an input into my function. So therefore, it's in the domain. So if we want to write the domain in interval notation, we see that up to -6, that's kind of like the first endpoint, but it is not included in it. So we're going to use a parenthesis to say it's not included. But anything greater than -6 is included. And then if I keep going, anything greater than -6 is included. All these x values after that do correspond to a point on my graph up to +1. But +1 has a filled in circle. That means it is part of my graph. So -1, when I plug it in, for example, notice that here, when you plug in -1, it corresponds to the point 1 comma -5. So that's just telling you that when you plug in -1 into the function, +1 into the function, it does give you an output, and in this case, it equals -5. But you don't really care about what the output is when you're looking for the domain. You just want to ask yourself, is 1 an input into my function? Is it defined? Yes, it is. So it is in my domain. So I'm going to include +1 using a square bracket. Okay. Now for range, it's a similar story, but you're looking at the y values. And you also want to do an increasing order. So I want to look at my y values on my y-axis from smallest to greatest. So notice that, for example, -7, there is no point with a y value -7 corresponding to my graph. So therefore, it is not an output value to anything of my function. But if I go up to -5, notice that -5 was an output to something. So because it was an output, it is an output to a particular input value. It is going to be in my range. So I'm going to start my range at -5, and because my circle is filled, I know that it actually does include the y value -5 as an output. So we're going to put a square bracket, and all possible other y values are also part of my graph. That means they're also output values to my function, right? Notice -3 is an output value here for this particular x value, and here for another particular x value. So it's an output value twice, but that's fine. You just need it to be an output value at least once for it to be in the range, right? Since it's a set of all output values. We keep going up, and we notice that at a +1, it kind of seems to stop. It tells us that that's where the last possible output value is. But because at 1 we have an open circle, this graph does not include a point that has the y value 1 as the output. Only y values up to 1, so like 0.9 is on my graph, so 0.9 is an output value, therefore it is in my range. But 1 itself does not correspond to a point on my graph, so it does not actually have, it is not an output value to any input value. Okay, so my y values in my range go up to 1, but because 1 is not included in my range, I use a parentheses to exclude it. Okay, so this would be the domain and range for this function. So notice that visually, it's telling us that for my function here, I'm only allowed to plug in x values between -6 and 1, excluding -6, including 1. And whatever I spit out in my function, whatever y values I output, will range between -5 and 1. But it does include -5, and it excludes +1. All right.